Hello my friends, and here we go with the very last tutorial of this AI A to Z course. I'm very excited, but at the same time a bit sad to finish this course with you because I had so much fun building all these AIs with you. We did some fantastic work together and we built indeed several powerful AIs. And so now we're just gonna do some little final polishing work, some final tuning work on our A3C model thanks to ChatGPT. We're just gonna ask ChatGPT if it has some suggestions on how to improve our A3C model. Basically, we're simply going to ask ChatGPT to build an A3C model implemented with PyTorch for the Kung Fu Master environment, and we'll see what it comes up with. Alright, so let's do this. Let's say first, hello ChatGPT, can you please implement the A3C model in PyTorch for the Kung Fu Master environment. Alright, I think it's spelled this way, without the spaces. There it is, okay? Kung Fu Master. So here we go. Let's ask this to ChatGPT and let's see what it comes up with. Here we go. ChatGPT is now thinking, and sure, I can help with that. The asynchronous advantage actor critic, there we go, it's the right model, that's a good start, is a reinforcement learning algorithm that combines both policy gradient and value function methods, absolutely. It uses multiple agents in parallel to gather diverse experience and update a shared model asynchronously, perfect. To implement A3C in PyTorch for the Kung Fu Master environment, which is likely from the OpenAI engine, absolutely. We need to follow these steps. First, set up the environment, import the necessary libraries and initialize the Kung Fu Master environment, so that's totally what we did. Define the model, create a neural network model that includes both the actor and critic components, that's what we did in part 1. Define the agent, implement the agent that interacts with the environment, collecting experience and learning from it. That's what we did kind of in the agent class. Asynchronous training, set up multiple instances of the environment, each with its own agent, and train them asynchronously. That's kind of what we did with the end batch class, but then also with the training loop. And there we go, the training loop. Speaking of which, implement the main loop where agents interact with the environment and learn from their experiences. Let's start by setting up the environment and defining the model. We'll use PyTorch for building the neural network. So here we go. Let's see what code it comes up with. I'm mostly interested to see the architecture, if it's going to have the same, layers, convolutional layers, number of neurons inside. Here we go. So, of course, first we install Torch, but we don't have to do it because we use Google Colab, so perfect. And then, now, let's begin the implementation. I'll provide the code for the first 2 steps, setting up the environment and defining the model. Then we can proceed with the remaining steps. Absolutely, let's do it. Alright, so here we go. Analyzing. Okay, by the way, I am with ChatGPT 4 and I'm using GPT-4, the latest version. Alright, so now it is analyzing and it will soon start the code generation, as it is indeed one of the features of ChatGPT. It can not only do text generation, but also code generation and now image generation with the DALL-E 3 integration. So there we go. Right now it's analyzing and very soon it will start the code generation. And I can't wait to see if, first of all, it provides a similar architecture to the one we use. By the way, I've prepared it right here. That's our architecture, remember, with 32 input channels and output channels in most of the convolutional layers. And so that's the first thing we'll compare to. Error analyzing. Okay, so, no, there we go. Okay, so I don't know what happened, but here is the code. So let's have a look at it together. And, okay, so very interesting. It has a very different architecture, as you can see. First, it starts with a fully connected layer of 256 hidden neurons, then 256 hidden neurons. Okay, so I see what it does. It does create a fully connected layer for the actor and another fully connected layer for the critic. Okay, so basically, it's similar to what we did, but remember, instead of calling them self.actor and self.critic, we call them, let's have a look at it again, we call them self.fc2a and self.fc2s. That's the final full connection leading to 2 separate output layers, one for the action values and one for the state value. So that's what it does here, but it calls them actor and critic, okay? So that's fine, but we forgot to specify, well, actually I specified that the environment is Kung Fu Master, so ChatGPT didn't know that actually the input state in the Kung Fu Master environment are actually images. That's why I did not provide here some convolutional layers, but we can specify this in the next prompt. But there we go. That's what it chooses for the fully connected layers leading to the 2 final output layers, one for the action values and one for the state value. Okay, so then we have the Ford method with a softmax policy. Okay, so that's good, just like what we did. Okay, so it uses Kung Fu Master V0 and nothing after. Okay, so ChatGPT did not do well here, and plus there was some kind of error generating this response. So yes, there we go. So there is an error. So what we'll do now is not regenerate, but actually, since ChatGPT did not understand that the Kung Fu Master environment has actually this 4 grayscale frame buffer as the input state, well, we will specify this now. So I'm copying this, and instead of regenerating the response here, I'm gonna open a new window because ChatGPT seemed a bit lost here. I was hoping we could finish this course, on a good note, but let's not give up. I'm sure we can do this. I'm sure ChatGPT can do it. So here we go. Let's start again. So I'm going to paste what I did before, and I'm going to add here, remember, well, I don't know if it remembers or if it simply doesn't know, but I'm going to say, remember that in the Kung Fu Master environment, the observation space is as such. All right, and we're simply going to go back to, Gymnasium, and we're just gonna copy this. All right, and that's for Kung Fu Master V5, but let's not make it too difficult for ChatGPT by saying that we're working with, in fact, Kung Fu Master deterministic. That's fine, let's just keep this, and we can even provide the action space, actually. I'll do that as well, so that ChatGPT can know exactly what we're dealing with right now in this environment. So, here we go, observation space. Okay, I'm going to do that, and then I'm also going to provide the action space. I'm going to say, and the action space is as such. All right, we're going to go back to our Kung Fu Master environment. I'm going to copy the action space. I'm going to paste it, well, right here. Here we go, just like that, and I think that's it. I think we provided enough details now to ChatGPT, so let's hope it's going to come up with a better code generation for our A3C model. So are you ready? 3, 2, 1, go. All right, ChatGPT, second chance. Implementing the asynchronous advantage actor critic A3C model in PyTorch for the Kung Fu Master environment from OpenAI's Gym, absolutely, so far 100% correct, is a multi-step process. Yes, for sure. We will start by setting up the necessary components. All right, so that we know, okay, environment setup. We'll use the Kung Fu Master environment from OpenAI's Gym, which has the observation space and the action space you described. Okay, so no, good. Now it knows what the observation space and action space are. Then the A3C algorithm. The A3C algorithm involves both an actor for choosing actions and a critic network for evaluating them. Absolutely correct. And then PyTorch implementation. Okay, the model will be implemented using PyTorch, a popular deep learning library. Yes, I remind that this is the most powerful one. It is more powerful than TensorFlow, so it's better to implement it with PyTorch. Let's begin by setting up the environment and defining the A3C model. I will write the code in parts explaining each step. Okay, first we need to install the necessary libraries. You can install them using your Python environment using pip. Okay, so that's already installed for us, all good. Then importing the libraries, we'll need to import PyTorch and Gym along with some other necessary modules. Okay, so that's done as well because we're using Colab. So all good with this so far. I'm just interested in the architecture and the algorithm that it implements. Maybe it's gonna add some tricks or add some, features of reinforcement learning that we might have forgotten or, that we might have not thought of that will considerably improve the final score. And so there we go. Defining the actor-critic network. This network will have 2 heads, one for the actor and one for the critic. Yes, I like how it, uses this metaphor, 2 heads, like 2 brains, So there's going to be 1 brain for the actor and 1 brain for the critic. So that I like, that's pretty nice. Okay, so this time it implements the eyes, right, with the convolutional layers, and that's because we specified that the observation state is actually input images. Okay, so that's good. So we have our convolutions now, and by the way, it now uses almost similar convolutions as the ones we did. Well, we stayed at 32, but here they increase, the channels from 32 to 64, then 128, and finally 128 for the fully connected layer. So you can try that actually in the implementation, and you can see if it improves the training and the final score. And please, if it does, please share in the comments. I'm super curious to know, and I can even record a new tutorial with the improved results and the improved algorithm or the improved architecture. And then there we go. We have the Ford method that forwards propagate the signal from the input images up to the final output layers. All right. So here we go. Now implementing the A3C algorithm. So A3C uses multiple agents processes to explore the environment and update a shared model asynchronously. Yes, we got that. This part can be quite complex as it involves multiprocessing and careful handling of gradients. We need to define functions for the worker processes that interact with the environment, calculate gradients, and update the shared model. Okay, very good. All right, so it defines a function, okay, not a class, to implement the A3C algorithm. Why not? You know, we can totally do this with a function as well. And network error again. Okay, so not sure what is happening now with ChatGPT. I'm pretty sure my internet is completely fine. So it might be a problem of servers that ChatGPT is using. Maybe they need to upgrade their servers. You know how so much people are using ChatGPT and maybe it has reached full capacity. But anyway, that's totally fine. We have most of the information I was looking for actually at this point, because indeed I was mostly interested in seeing an alternative architecture, which is this one. So you can try that. Please let me know which training results and which final score you get in the comments. And if we have a much better score, I'll be super happy to re-record, you know, a new A3C tuning tutorial with those improved results. And then the second thing I wanted to check was the optimizer it uses, and actually it still uses the Atom optimizer. So I think we're good with the other part of the algorithm, and plus it uses, as you can see, the same learning rate, right? 10 at the power of -4. Which learning rate did we have exactly? Let's have a look at it again. I think we had the same one, no? Initializing the hyperparameters, and there you go. You see, it's the exact same learning rate. So that's interesting as well, you know, to see the different hyperparameter values that ChatGPT suggests, and we have the same learning rate, okay? So there we go. I think that's enough from ChatGPT, even if it could not finish the code generation. So my suggestion to you is, you know, it will be very good for your practice, is to try that architecture with our same code. You know, you just replace the number of neurons we had, which is 32, by these numbers of neurons here in the convolutions, and even in the full connection, but I think it's the same, right? We also had 512. Let's have a look at it again. And there we go. We had 512 for the first fully connected layer, and then 128 for both the final output layer for the action values and the final output layer for the state value. So actually here in ChatGPT, it does kind of the opposite. It starts, you know, in the first full connection with 128 neurons, and then for the two final output layers of the action values and the state value, it uses for both of them 512 neurons. So you can try that as well. You know, they inversed what we did. So feel free to try that. And please, if you get a much higher score, please share that in the comments. I'll be super curious and happy to see by how much you managed to improve the results we got together. All right. So again, thank you so much and massive congrats for having reached the end of this course. You did some awesome work and you're now among the top experts in artificial intelligence, because, you know, most people today are using ChatGPT to directly implement the models, but you wrote every single line of code of the AIs we built together, and that gives you a significant advantage compared to the rest of the AI scientists. So huge congrats for that. Please, let's keep in touch. You know, I'm very active on LinkedIn. I'm also very active on the different social media. And also, of course, I'll create some other AI courses. So please don't hesitate to reach out to me. I'll be super happy to discuss AI with you. And perhaps one day we'll meet at a conference to discuss AI further with a good coffee or a good tea or a good OJ, but this time in real life. All right? And now my final words to you are never stop learning. And of course, enjoy AI.